Although it isn't the Great Salt Lake, Utah Lake is the third largest lake in the western United States and stands as a trademark to Utah. Utah Lake is 145 square miles of freshwater with an average depth of 9 feet and a maximum depth of 19. This lake has been important to Utah Valley, ecologically, economically, and environmentally for years. Before settlement, this lake was home to 13 native fish species, multiple plant communities, and dozens of native mollusks. This created a beautiful and perfectly intertwined food web and ecosystem. The first known settlement of the lake region was in about 10,000 BC by Native Americans. The lake provided a place for hunting, fishing, and farming. By the 1800s, the lake was shared by three groups: the Paiutes, the Utes, and the Shoshone. For hundreds of years, this lake provided nourishment and community for the people who inhabited the land. Whether it was for commercial fishing, transportation, or irrigation, Utah Lake was definitely being put to use. In 1948, a sewage disposal study was held on Utah Lake, and they found the lake was being seriously polluted. Towns started to design and implement sewage treatment plants. Despite their efforts, raw sewage was still making its way into Utah Lake all the way up to 1967. Today, Utah Lake's largest threat is harmful algae blooms, or HABs. These HABs are dangerous to humans, plants, and animals, and can upset the ecosystem of the lake. Cyanobacteria, present in HABs, release harmful toxins that can affect people and animals. These HABs also contribute to overgrowth in the lake. All of this organic material causes a decrease of oxygen in the water and results in dead zones where no living creatures can live. HABs are formed in environments with high levels of phosphorus and nitrogen, usually as a result of anthropogenic nutrient pollution. Utah Lake stands at a higher risk for these algae blooms because of its shallow nature. This causes more interactions between the water, soil, and atmosphere. A study held by Matthew Randall in 2019 investigated the phosphorus concentrations in Utah Lake and their links to the HABs present. By taking many samples from different areas of the lake and surrounding lakes, Randall found that areas with more phosphorus had more HABs as well. From this figure, we can see that the east side of the lake had the most concentrated samples of phosphorus. This is the same area where a majority of algae blooms flourish. Randall discusses that these high phosphorus levels lay a foundation for HABs. Although further research needs to be conducted to investigate other chemical concentrations that play a role in the production of HABs, we can take this study into account when coming up with lake restoration plans. Phosphorus can enter the lake in multiple ways. For example, the water runoff from gardens can cause the amount of external phosphorus that enters the lake to increase. This is because planting soil contains large amounts of phosphorus. Dr. R.D. Ghilotti conducted research about plankton ecology and biomanipulation as a way to restore lakes in the Netherlands. The lakes that Ghilotti researched were shallow body lakes and had similar characteristics to Utah Lake. Dr. Ghilotti found many interactions and feeding patterns between the zooplankton and phytoplankton in the lakes. To reduce the amount of nitrogen and phosphorus in the lakes, Ghilotti fed the zooplankton an alternative diet. This process is a form of biomanipulation. We can incorporate these same biomanipulation techniques into Utah Lake to decrease the amount of HABs. Utah Lake has provided so much to the community for hundreds of years. We must take the responsibility to address this issue now before it's too late. This can help ensure future generations can enjoy the lake as well.